the circuit is now ready for compilation. There are some options here for compilations. These purple arrows are for compilation. If you use start compilation, it just start the whole series of compilation which is needed for uploading this circuit to the chip. But we are not going to do that. We are going to just analysis and synthesis the circuit, not uploading the compilation to the FPGA. Then we use start analysis and synthesis compilation. We should save the block diagram we have created. Just name it as it suggested to us, first project, and we can save it. Okay, analysis and synthesis is successful. There are some infos here and here. You can read all the infos, and there are some useful information. For example, sometimes we have warning. In the worst case, we have some errors we should solve them to be able to simulate our design. For example, there are some information here. For example, total pins are 4, total logic elements, total combinational functions, and so on. Then then the compilation is now completed, and we are ready to simulate and see what exactly we can do with this circuit to see by different inputs what is the output. Okay, from file menu, click on new, and under verification and debugging files, click on vector waveform file. In this section, we should add our pins, we should add our pins to waveform file section to give them some inputs and receive some output. In this area, right click and click on insert node or both. In this menu, in this window, you should click on node finder, and here in filter option you should select pins all, and then click on list. It lists all the inputs and output pins we added to our block diagram file. Click on X1 and hold shift to add X1 to X3 to selected nodes, and also output. We need all of them for simulating our project. Click on OK, and again OK, and we have added all the input pins and output pin to our waveform editor to see what will be happened when input changes in the output. Okay, in this section you should give some values to x1, x2 and x3 to see what will be the result. Click on x1, right click on x1, and from value menu click on clock. There is some time range options, start time and end time. Let them default as they are 0 picosecond and 1 microsecond is the end time. And for time period, you just change it to 5 nanosecond, and duty cycle of 50% is good, and click on OK. As you see, there is a clock now on x1 input, which in every 10 nanoseconds it's high 5 nanoseconds and it's low in other 5 nanoseconds, and it's going to clock to the end of the time. For x2, right click again, click on value and then clock, and just double the period. It's now 10, and as you see the clock is 10 nanoseconds and duty cycle off. Duty cycle means when the signal is high. You see that 5 nanoseconds is high, 5 nanoseconds is low. And for x3, click on value and clock again and just double it, 20 nanoseconds. Now we have created some signals for our inputs in this file, and we are ready for simulation. The shaded area here is because there is nothing for output yet, because we are not started simulation. Okay, go to processing menu and use simulator tool. There is a very good simulator tool here. There are some options for simulation mode. We are not going through timing mode because it's based on hazards and gate delays. We are not going to focus on this this mode of simulation. Just need to see what is the functional result of this function. Then select functional and click on generate functional simulation netlist. You should save changes to waveform, click on next, let it be the name it suggested and click on save. Function simulation netlist generation was successful. Okay, and now we should select the first project waveform from this one. Okay, and click on start simulation. Simulator was successful, then everything is good, and now we just see the report. Okay, this is the report of simulation. As you see, when x1 and x2 and x3 are 0, output or f is 0. We can check from truth table this fact. When x1, x2 and x3 are 0, the output f is 0 too. If x1 is 1 and x2 and x3 are 0, which is this line, as you see, the output will be 0. And if, for example, for this section, if x1 and x2 is high or 1, x3 is 0, the output should be 1. And as we see, when is 1, 1, 0, the output is 1, and so on. You can check yourself the result of project with the truth table, and you can design other functions using Quartus 2 to see the results. I hope you learn how to create your function using Quartus 2 from schematic file and using block diagrams, and how to simulate them using the waveform from Quartus. Thank you for watching this video tutorial.